Alright, we're looking to find the derivative of inverse functions in this video. So if we're talking about an inverse function, recall from last year we used this notation to represent an inverse. So f raised to the negative 1, okay, so f inverse is the way we say that, okay. Sometimes we'll just write it like this without the x, okay. So what's happening here in this first example is, suppose our function f of x is 3x plus 2, which contains the point 2, 8. Notice if you were to put 2 in for x, you would get 8 out for y. So the point 2, 8 is on f of x. What we're looking to find here is the derivative of f inverse of 8. So this is a derivative mark here on the end. It's kind of crooked. So another way of thinking about this is you can write this as f inverse, okay, with a derivative mark there, of 8. Okay, so we're trying to find the derivative of the inverse function at the x value of 8. So to help us understand this, let's actually find our inverse equation. So if you recall from last year, the way to find an inverse is to switch x and y and solve for y. So if I were to subtract over 2 and then divide by 3, x minus 2, x minus 2, that's a minus. Let me write this again, sorry. So x minus 2 all over 3 would equal y, and then we said to replace y with your inverse notation. So the inverse equation would be that. Now notice that if we were to divide each of these by 3, the slope, which we call m, would be 1/3. Okay, so the slope is equal to 1/3 on this inverse equation. So if I were to separate this a little bit and rewrite it, we're really talking about 1/3 x minus 2/3. That's what our equation would be if we were to separate it. So let's graph that just to get a feel for what's happening. Well, recall that if 2, 8 is on f, then 8, 2 is going to be on f inverse. So if 2, 8 is on f, we know that 8, 2 is going to be on our inverse graph. So let's plot that. Let's plot 8, 2. Okay, so let's say it's about here. And recall that if we are graphing an inverse and an original function, it's really going to be a reflection over the line y equals x. So if 2, 8 is on f, then 8, 2 is going to be on our inverse. So if we were to graph this, okay, it's going through that point 8, 2. Okay, so it's a reflection over that line, y equals x. So this is my inverse graph. Okay, so if we want to try to find the slope of that, we mentioned that it's always going to be 1/3 because it's a line, and you can see that the slope is 1/3. So the slope here is 1/3. If we go back to our original function, notice that the slope is 3. Slope of this line is 3. So we're trying to find the slope, back to this, we're trying to find the slope of the tangent line at x equals 8 on the inverse graph. So here is our point when x equals 8. The slope, notice, is 1/3. So the answer to the question is going to be 1/3. So we just found the derivative of an inverse function at a particular point. So let's try to summarize what we just found, or what we noticed. So the slope of the original one was 3. The slope of the inverse was 1/3. So it looks like the slopes of the tangent lines are reciprocals. Let's write that down. Slopes of tangent lines are reciprocals. Not opposite reciprocals. We didn't switch any signs. We didn't negate anything. Okay, we just simply took a reciprocal. So this is a key point that you're going to want to remember. This is your formula, so to speak. All right, this is our major concept that you're going to want to remember as we go through these problems. And we're just looking at 3 today in this video, and then in class we'll look at a lot more. But the idea here is if we were to actually find our inverse equation and look at the slope, it would be the opposite reciprocal, okay, from the original one. So let's look at another example. And in this next example, we're going to notice that we're not going to be able to find the actual inverse equation. So imagine switching x and y here. So if you were to switch x and y and then attempt to solve for y, we're not going to be able to do that. All right, it's too difficult to solve for y algebraically. All right, so we're not going to be able to find our equation. Okay, so this here I'm just going to put a question mark by. All right, it's not going to help us. All right, we can't find f inverse equation. So we're trying to find in this problem the derivative of the inverse function when x is 3. Well, notice they tell us that here's our function and it includes the point 1, 3. So if I put 1 in for x, notice you get 3 out for y. So if we keep this concept from up above in mind, if we can find the slope of the tangent line of the original function, then we could find the derivative by just taking the reciprocal. Now notice that if we go back up above here, notice, let me grab a different color. Notice that what we were trying to find, it was an x value of 8. Okay? That x value of 8 showed up as a y value on the other function. Okay? That's going to be the case in these questions. So down here, notice that the x value we're trying to find, all right, the derivative of on the inverse, shows up as the y value of this other point. So if we can find the derivative at 1 on f of x, we know that it's going to be the reciprocal for 3. So find your derivative, f prime of x. Okay, so 3x squared plus 2. Pretty simple derivative there. If we can find the slope of the tangent line at 1, now I'm picking 1 because that is my x value here. Okay, if I put 1 in there, notice I'm going to get 5. Okay, so what this is suggesting is that the slope of the tangent at x equals 1 on f is 5. So if I want, what this is asking for is to find the slope of the tangent on f inverse at x equals 3. Well, because if 1, 3 is on f, we know that 3, 1 is going to be on f inverse, just like we saw with the 2, 8 and the 8, 2 up above. Because that is the case, all right, we know that the slopes of the tangent lines are going to be reciprocals. So our answer here, the reciprocal of 5, would be 1 over 5. Again, we're not doing an opposite reciprocal. You just flip it, okay? Keep the sign the same. One more. So in this problem, we have an f of x given to us with this point. So if you were to put 2 in for x, you'd get 45 out for y. We want to find the derivative at 45 on the inverse. Well, again, notice that this 45, it's an x value. Oops, it's an x value on the inverse graph, and it's also a y value on f. Okay? It's always going to be the case in these problems. So go ahead and find your derivative of f, so f prime of x. So that's going to give us 12x cubed minus 2. And now we're going to find the derivative at the x value of 2. Okay, so 12 times 8 minus 2 is going to give us 94. If we want to now find the derivative of the inverse at 45, it's just going to be the reciprocal of 1 over 94. So going back to this right here, if we know that you have 2/8 on one and you're trying to find the derivative at 8 on the other, okay, again, if 2/8 is on one, 8/2 is on the other. All right, if you have that situation going on, the slopes of the tangent lines are going to be reciprocals. In other words, the derivatives are going to be reciprocals. Okay, so that's a start. We'll look at some more examples in class, like I mentioned. Okay, but that's the basics starting off. Goodbye.